So now we will move on to the second problem. So sketch the Bode plot for the following transfer function and determine the phase margin and gain margin. Here the problem is g of is equal to this one. Here, what is the first step? We have to ensure the problem is in standard format. Right? So here the problem contains the first order term 1 plus 0.2s, s integrative term, s square plus 16s plus 100. That is second order term. Right? So we know that the first order term, if it is available as the numerator or denominator, that is 1 plus st, this is the first order term, then the corresponding corner frequency is, then the corresponding corner frequency omega c is equal to 1 by t, right? Similarly, for the second order system, that is omega n square divided by s square plus 2 epsilon omega ns plus omega n square. This is the second order system. For this system, corner frequency is dependent on the natural frequency. That is omega c is simply the natural frequency omega n. This you have to keep in mind for proceeding this problem, right? So this one. Now we'll go to the procedure as usual, right? So what is the step two? So what is step one or step two? That is we have to find out the equivalent frequency response from the transfer function g of s. So frequency response, what is the meaning? G of j omega we have to find out from g of s. So what you have to do? We have to replace s by j omega. We have to replace s by j omega, right? So after that, we have to replace s by j omega. So now I'm replacing s by j omega. So here, what is the equation? G of j omega equal to, how it will be changed? 75 into, and before that, let me remodify the given g of s into a standard format for finding the omega n square value. For that, let me convert it. G of n is equal to 75 into 1 plus 0.2s divided by s into, let me take 100 outside. Let me take 100 outside. How it will be? S square divided by 100 and plus 16 s divided by 100 and plus 100 divided by 100. What is the value? That is 1. So let me make it like this for my convenience. Now what is 75 by 100? 75 by 100 is what? My value is 1. 75 by 100, the value is 1. So now 75 by 100, the value is, sorry, 0.75. 0.75 into 1 plus 0.2s divided by s into, here s square by 100, 16s by 100 and 100 by 100 is 1. So 1 plus 16 s by 100, let me rearrange this, and plus s square divided by 100. Now this is the conversion I have considered, right? Now this is the conversion, right? So now we find the g of j omega. What is g of j omega? You have to replace g of s over g of s, has to be replaced by g of j omega. That means 0.75 instead of 0.2s, let me consider 1 plus j 0.2 omega. Similarly, here we have to replace it by j omega. Here, what will do? 1 plus 16 s equal to j omega. So, s j omega divided by 100. Similarly, here instead of s square, you have to put down j omega the whole square divided by 100. So, these were the term. Now, we have to simplify it. That is g of j omega, which is equal to 0.75 into 1 plus j 0.2 omega divided by j omega into, here let me consider j square equal to 1 on omega square. So let me make it 1 minus omega square divided by 100 plus j times 16 omega divided by 100. So this is what the frequency response, right? So this is the step number one. Now, that is step number two. You have to find out the corner frequency. Step number three. So you have to find out the corner frequency. See, depending on the problem, we can change the step. There is no issue. So you have to find out the corner frequency. So what is the meaning of corner frequency? So here we have an integrative term. Here we have an integrative term. What is this? 1 by s and here we have 1 plus 0.2s and this one, right? So we know that first order term corner frequency is omega c equal to 1 by t. For the second order term corner frequency is omega n, as we know already, right? So now here the term first term is 1 plus 0.2s, that is available in the numerator, that is 1 plus 0.2s. 1 plus 0.2s. The corresponding frequency is corner frequency is omega c1 equal to 1 by t. Here instead of t, what is the value we have? 1 by zero point 0.2. So 1 by zero point 0.2 is what? Pi radian per second. So this is the corner frequency number 1. Similarly, for the term 1 divided by, what is the term we have? 1 divided by 1 divided by s square plus 16s plus 100, right? So the 16 square plus s square plus 16s plus 100. So we know that the standard second order term equation is s square plus 2 epsilon omega ns plus 100, right? So omega n square, sorry, no, omega n square plus omega n square, right? So s square plus 2 epsilon omega ns plus omega n square. Now compare both these value and tell me what is the thing we have to come across. So s square plus 16 is, right? So what is the thing? By comparing both these value, what we can conclude it, right? So we can conclude like 2 epsilon omega n equal to 16 and omega n square equal to what? 100. So omega n square equal to 100. So now what is omega n? Omega equal to 10. If we are substituting omega equal to 10 in this particular equation, we have 2 epsilon into 10 equal to 16. So now what is epsilon? That is damping ratio. That is 16 by 2 is 8. 8 by 10 is 0.8. So this is the value, right? So now we found that omega n equal to 10 for the quadratic term or second order term. So now the corresponding corner frequency for 1 by 1 divided by s square plus 16s plus 100 is the corresponding corner frequency omega c2 is nothing but omega n, which is equal to 10 radian per second that we found recently. So this is the step number 3. So now after that, what you have to do, you have to put a table according to the corner frequency and the term. So you have to prepare a table. So what is the table we are going to prepare? We know that the table contain how many terms? The table contain how many terms? Yes. So the table contains the 4 columns, right? So what are the 4 columns? So column number 1 is terms. That is column number 2. It is the corner frequency, right? And what is column number 3? Column number 3 is slope rate. And what is column number 4? That is change in slope, right? So these are all the things you have to remember, right? So we know that the unit of corner frequency is radian per second. So we can put it at the heading. And slope rate, the unit is dB per decade. For change in slope also dB per decade. So here, right? So now what other terms are there? What other terms? Here you have to look at. So now tell me what other terms are here. See here the terms are this one. 0.75 divided by j omega is the first term. So this is the first term. The term, this is the first one. 0.75 divided by, here let me mark it. Yes. Yes. 0.75 divided by j omega is the first term. And 1 plus j 0.2 omega is the second term. And this 1 minus omega square divided by 100 plus j, this is the third term. Now I have to list out all these things. So 0.75 divided by 100 is the first term. 0.75 divided by s is j omega. Not s. 0.75 divided by j omega is the first term. The second term is 1 plus j point. You can ask one question, sir, why you keep 1 plus j point 2 omega is not the first term? Definitely the question may come, right? But remember, guys, always you have to list out the corner frequency according to the descending order. Since we don't have any corner frequency for the term 0.75 divided by j omega, that one I am keeping as the first term rather than the 1 plus j point 2 omega. That is the reason, right? Now, the third term is 1 minus omega square divided by 100 plus j omega 100. So, 1 minus omega square divided by 100 plus j 16 omega divided by 100. So, these are the terms. Now, we have to find out what is the corner frequency, what is the slope rate and change in slope. Now, tell me guys, what is the value? So for 0.75 divided by j omega, you know that this is a first order system. So first order system, the value is what? The value is, I mean, for this is first order system. This is not first order. This is integrative, so there is no corner frequency. What is slope rate? This is 1 by s. So 1 by s means minus 20 dB per decay. So minus 20 dB per decay. Now what is change in slope? What is change in slope? Since there is no change in slope, the first value. What is 1 plus j point 2 omega? See, since whatever the problem we have seen like 1 by 1 plus j zero point 0.3 omega or zero point 0.2 omega we have seen. Now this problem, there is this factor is coming at the numerator. For this one, the corresponding slope is minus 20. If it is coming at the numerator, then the value is what? Plus 20. So plus 20 is the slope rate. We know what is the corner frequency. Omega C1. We have calculated recently. That is 5 radian per second. That is what we have calculated as a previous step. We can see that. Omega C1 equal to 5 radian per second. What is this one? Omega C2. That is corner frequency for this one is omega C2 equal to, for this one, that is simply omega n. Omega n is 10 radian per second. These also we have calculated recently. Now tell me guys, for the quadratic factors, what is the slope rate? That we know 1 by s square plus 2 epsilon omega ns plus omega n square. This is a quadratic term or second order term. If it is a second order term is coming at the denominator, I have told you the slope rate is minus 40. If it is coming at the numerator, the value is plus 40. So now here it is coming at the denominator, so let me put on minus 40. Now here the value is minus 20. So here the value is plus 20. So my change in slope will be minus 20 plus 20. So the my answer is 0 dB, right? So here the value is 0, here the value is minus 40, so my answer is 0 minus 40, so the value is what? Minus 40 dB. So these are all things we have to remember, right? So this is the second step or third step. Now after that, what you have to do? You have to prepare a magnitude plot. If you want to prepare a magnitude plot, you are in need of frequency versus magnitude, or magnitude versus frequency. We are going to plot it. So now we have to consider different frequencies. So what are the frequencies we can consider? Usually omega c1 is there and omega c2 is there. What is omega c1? That is 5 radian per second. Omega c2 is 10 radian per second. What is the thing we will consider? Usually omega l and omega h. Let me consider omega l equal to 0.5 and omega h equal to 50. This is the assumption. You can consider any value, right? So after this, what you'll do? You have to consider g of j omega at omega equal to omega c1, omega equal to omega c2. So we'll consider it, right? So g of j omega at omega equal to omega L. So what is the formula? That is 20 log of, what is the term is there? 20 logarithm of, what is the term? 0.75 divided by j omega. That is 0.75. So the value is what? 0.75 divided by j omega is there. So for this one, you have to take the magnitude. So you know that what is the value? 20 log 0.75 divided by omega, right? So what is the value of omega here? 20 log, what is the value of omega? 0.75 divided by, instead of omega we have assumed that the value is 0.5, right? So the, what is the value? Tell me. 20 log divided by 0.75 divided by 0.5. So what is the value is that? You take a calculator and we will find out. So what is 0.75 divided by 0.5? 0.75 divided by 0.5 is 1.5. So for log 1.5 is 0.176 into 20. So the answer is 3.52, right? So the answer is what? 3.52. So now we have to replace it. Now we have to replace it to the answer by 3.5 dB, right? I hope you can able to understand, right? So what is the next thing we have to find out? Next, I have to find out the g of j omega at the value. Next, I have to find out g of j omega at which frequency? Omega equal to omega c1. These are all we know already, right? We have solved so many problems, right? So 20 log, same thing we'll use, right? 0.75 divided by omega, but instead of omega, which value you replace? Omega c1. Here omega c1 is what? 5. So 0.75 divided by 5. So what is 0.75 divided by 5? And 20 log. So 0.75 divided by 5 is what? 0.15 log we are taking into 20. So what is the answer? Minus 16.48. So minus 16.48 will be considered minus 16 dB. This is the second one. Now we have to do, we have to find out the third value. What is the value we are finding? G of j omega at omega equal to omega c2. Can anyone tell what is the logic we have to follow here? Anyone? Yes, absolutely. We have to follow the slope logic. What is slope logic? Since slope we are available from omega c1 earlier to omega c2, and what is the logarithmic factor of current frequency over the previous frequency omega c1? Both these values you have to add it with the previous magnitude values, right? So both these values you have to add it with the previous magnitude value, that is g of j omega at omega equal to omega c1. So now tell me first what is the value? Slope from omega c1 to omega c2. What is the slope? That is 0 dB. So 0 into, so what is this? This is the value is 0. So the value is what? 0 dB. So the value is 0 dB into log of omega c2 is what? Omega c2 is 10, 10 by 5. So log 10 divided by 5. This plus, what is the value of g or j omega and this one? Minus 16. Already we know that 0 into anything, 0. Minus 16. So here also the answer is what? Minus 16 dB. So this is the value at omega equal to omega c2. Now what is the thing next I have to do? We have to find out the g of j omega at omega equal to what? Omega equal to omega h. So we know here also we have to follow which logic? Slope logic, right? So it is slope. So slope from omega c1 to, sorry, slope from omega c2 to omega h into logarithmic factor of omega h divided by omega c2. That value you have to add it over, that value we have to add it over g of j omega at the previous. So omega equal to omega c2, right? So what is the value we have to follow it? Yes. Yes. So what is the value? Slope from this omega c2 to omega h. So look at the table. The value is what? Omega c2 to omega h is minus 40. So minus 40 times log of omega h is what? It is omega h. The value is 50. So 50 divided by omega c2 is what? 10. So 50 divided by 10. So plus, what is the earlier value? Earlier value is minus 60. So now log 50 divided by 10. So what is 50 by 10? 5. So what is log 5? So log 5 you have to take. Then that value has to be multiplied by minus 40. So the answer is, sorry. So log 5 has to be multiplied by, right? So fine. So 5 log 5, right? Log 5 has to be multiplied by the value minus 40. So log 5 is this one. So 0.698 has to be multiplied by the 40, right? I will change it. So minus 27. So minus 28, minus 28, minus 26 is minus 44. So that one I am going to write it over here. So minus 44 dB. So this is what the various magnitude. Now for this magnitude you have to find, you have to put the magnitude plot, right? So this is how you have to find the magnitude plot. We have to find the phase plot, right? So we have to put the heading as phase plot. So that is the step number 5. So we have to find out the phase plot. For phase plot, which equation we have to consider? We know it, right? So which equation we have to consider? We have to consider g of j omega. So what is g of j omega? This one, right? So this equation I am going to consider it. Yes. If we put it, so this equation, let me consider it. This one, right? Let me put it so that it is easy for you to no need to copy it again and again, right? Yes. So where I can copy it over here. Right. So this is the equation, right? Okay. Now this in this equation, what you'll do, right? So this is the equation. In this equation, let me find out the angle that is g of j omega, right? So let me find out the value g of j omega in degree, right? So this is in degree. So now what is the first point on base? Nowhere. 1 plus point j point 2. What is the angle that is tan inverse of imaginary part? Imaginary part is point 0.2 omega. Real part is 1. So tan inverse of point 0.2 omega. Similarly, here we have 1 by j omega. 1 by j omega already I have told you the value is what? 1 by j omega. If it is there, then the corresponding angle is what? 90. Is it correct? No. Since it is in denominator, you have to put what? Minus 90, right? Very good. So what is the value you have to put? You have to put 90 degree. So tan inverse of 0.2 omega, since the value is available in minus 90. Then this value. For this value, what will do? Minus tan inverse of imaginary part. What is imaginary part? 16 omega divided by 100. So let me make it into 0.16 omega. 0.16 omega divided by 1 minus omega square divided by 100. Can you make it like this? Tan inverse of imaginary part divided by real part. So this is what the equation for finding the phase for the given problem. Right? Okay. So this was the thing. Right. Now, again, tan inverse values are varying from tan inverse values are varying from 0 degree to minus 180 degree. But our calculator calculate tan inverse only between 0 degree to 90 degree. Hence, I am going to make the correction on 180 degree phase shift that should be added for after every value of omega n. What is the meaning, sir? That I will tell you while you are solving the problem. Okay. So next we have to consider usually, right? Next we will consider the phase usually, right? So what other thing you will consider? Next you will be putting a table like frequency versus phase. Frequency versus phase. So what is frequency is omega and the phase is what? G of j omega, right? G of j omega, right? So now what is the frequency I can consider? I can consider it from zero point 0.5, 1, 10, 1, 10, 20, 50, 100 if you want, you can do, or otherwise there is no need to work 100, right? So now you know how to calculate this value using calculator, right? While going for a phase, for this problem alone, let me make it into two tables, okay? For 180 degree consideration, let me make it into two tables, like for this one, what is this? Tan inverse of zero point 0.2 omega minus 90 degree. This value alone you'll be calculating using that alpha method I have told you know that one. For this also you have to find out minus tan inverse of 0.16 omega divided by 1 minus omega square divided by 100. You can calculate it alone, then you can add both the results together over here. That is our final phase g of j omega degree. Right? So it is tan inverse of zero point 0.2 omega minus 90 degree over the value 0.5. So the value is what? Here itself I will calculate it. Okay. Here itself I will calculate it. So tan inverse of zero point 0.2 omega minus 90 degree is, so the value, if you want, you can use the calculator and you can find out the corresponding value. So let me put the value directly. Okay. So tan inverse of zero point 0.2 into 0.5, the value is minus 90 is minus 84. Here the answer is minus 84. Here the answer is minus 84 degree. This one. This one minus tan inverse of zero point 0.6 omega divided by 1 minus omega square divided by 100. This one, the answer is 4.6. The answer is what? Minus 4.6 degree. Now the resultant what you'll do? This is minus 84 and this is minus 4.6. What is the resultant? This is minus 88 degree, right? So that's what. Next we will calculate it for 1. So for 1, so we have to find out this value. So this value is minus 78 This value is minus 78, and this value is what? For 1, the value is minus 9.2. So what is the final answer? Minus 98 minus. So the answer is minus 70, 87 degree. Right. So let me calculate it for 10. So let me calculate it for 10. So here for this term, the answer is minus 26.5. So let me take it down minus 26. For this term, the value is minus 116, right? Minus 116. So the answer is minus, sorry, the value is here for 10. Here the value is not minus 1. Here the value is 90, minus 90 degree. If you want, you can check it out. The final answer is minus 116 degree, right? From here afterwards, we have to look at very carefully, right? So here, when you are putting the value for 20, turn in the point 2 into 20 minus 10, 90. Here the table is what? Minus 14. Here the value is what? Minus 14 degree. But here the value is only plus 46.8 degree. Remember guys, this is very 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 important, right? So plus 46 point, here the value is 46.8 degree, right? So here this value is 46.8 degree. In this value you have to add it by the value. See, since there is no need to consider minus, so since again anyway we are going to add an equation. The table 2 has to be subtracted with table 3. This is the first practice, right? Because every time you bother about, you will forget about that minus. So that's why minus. Here also you can put minus 46.8. You will be getting this value. You have to add it by the factor 180 degree. Because why? Because is that we know that what is the natural frequency omega n, or what is the corner frequency omega n? The value is 10 for this problem, right? Up to the corner frequency, you have to use the normal calculation. After that, for this term alone, you have to add the value by 180 degree by the each term. Whatever the value you are getting, right? Whatever the value you are getting, here you'll be getting minus 46.8. For this one, you'll be getting minus 18.4. Here you'll be getting minus 92. Right? In this term, you are adding with the extra factor called 180 degree. Extra factor, you are adding it by 180 degree. Here adding, here we are adding, here also you are adding. Why? Because is that in quadratic factor, the phase values are varying from 0 to minus 180 degree, not 0 to 90 degree, remember. But our calculator have the provision to calculate the values from 0 to 90 degree, 0 to plus or minus 90 degree. And that case, you can't go for the 180 degree case. For that is the purpose, I am adding each value by 180 degree after the natural frequency or corner frequency omega n. That's what, right? So this is what the thing that I want to communicate to you, right? So this is minus 14, and here we have the values for 50. The value is minus 5.7. So 5 degree I will put it down. For this one, for 100, the value is minus 3 degree, right? So this value minus 14, and this answer is, when you're adding it, the answer is become 133.2 degree, and here the answer is 161.6 degree. Here the answer is 170.8 degree. Now this minus 14 has to be subtracted over this one. So final answer is minus 148 degree, and here the answer is minus 168 degree. Here the answer is minus 174 degree. I hope you can able to follow this. For the corner frequency, see, look at here. We have the provision in our calci to calculate tan inverse only for 0 to 90. But for the second order quadratic factors, the value may vary from 0 to 180. For this one, after the natural frequency or after the corner frequency, I am adding by 180 degree at each and every term. That's what I am doing. Yes, I hope we can able to follow this. So for this phase, try to plot it in the given graph. That's all. Right? So these are the things in the phase plot. Now I will go to the phase plot section. Yes, I'll show it in this one, this also, because I don't want to waste the time by plotting the points or boring with the things, right? So what is the first value? What is the first value? Let me go down and I'll tell you what is the first value. Yes, Here we have, right? So what are the values, right? So zero point 0.5 comma 5. So I'll write down the values and I can copy it. Zero point 0.5, what is the value? The value is 3.5. So for the 5, what is the value? Minus 16. For 10 also, the value is minus 16. For 15, 50, the value is what? For 50, the value is minus 44. So these are all the values. So these are the values. So let me make it. So these are the values. So let me copy it. So instead of going and dragging, so let me copy it and I will paste it over here. Okay. So this is my magnitude plot. Similarly, for phase, what is the value? Phase, these are the values, right? So these are the values for phase. So this is what the phase. Okay. Right. So this is the phase value. So now it is easy for you to take the thing. So it is zero point 0.5 comma 3.5. You can see that zero point 0.5 comma 3.5. So here let me consider. So here since the values are ranging from 3.5 to minus 50, so I am giving more importance for negative. So here they are considering, instead of considering 50, they are considering up to 20, it seems, right? So in this problem they are considering up to 20. If you want, you can consider up to 50. Here we may extend 50 comma minus 54 is also there, right? 50, 50 is here, right? So the 50 is here, 50 comma minus 44 is also you may consider. Here I am considering only 5 dB per axis, right? So t comma minus 44. So you can extend it. If you want, you can extend it. Even instead of considering this is as a t, you can consider this as a t. But the slope rate is not changing. Minus 20 dB per decade, 0 dB per decade, and minus 20 dB per decade. You can see it, right? This is the point A. You know, right? Zero point 0.5, the value is mine. Zero point 0.5, the value is what? 3.5. 5, the value is minus 16. You can see that. 5, 5, the value is what? Minus 16. You can see 5, the value is minus 16. Similarly, for 10 also, the value is minus 16. So 10 also, the value is minus 16. Next, 50 comma minus 44. So 50. So here I am considering the value is 50. So 50 comma minus 54. So this is the magnitude plot. Next, what is this phase plot? For phase plot, you are considering zero point 0.5. The value is minus 88. 1 minus 87. So here you can see that minus 88, minus 87. For the you can see E, F, minus 88, minus 87. Each and every value you can see it. Yes. I hope you can follow this. Right. What is the next one? For 10, the value is minus 160. For 10, the value is what? Minus 160. For 10, the value is what? Minus 160. So here, in between 100 and 120. Yes. And for what is the next value is 20, the value is minus 148. So 20, the value is minus 148. So likewise, you can see that each and every value is plotted. Right? So now we can connect all these points to draw the phasor plot. And here you can connect all these points to draw the magnitude plot. Now the problem is over? No. Here you have been asked to find out the gain margin and phase margin. You know how to, what is the meaning of gain margin and what is the meaning of phase margin? Anyone did you remember what is the meaning of gain margin? Yes. Gain margin is very simple, right? What you have to do is that you have to project minus 180-degree phase plot value is to be projected over which plot is to be projected over magnitude plot or gain plot. I hope you can follow this. Similarly, for finding phase margin, first you have to find out pi gc, that is phase gain crossover frequency. That is nothing but phase gain crossover frequency is nothing but what is the phase at gain crossover frequency. You know what is the meaning of gain crossover frequency? Gain crossover frequency is nothing but what is the 0 dB gain? What is the frequency corresponds to 0 dB line? Frequency corresponds to 0 dB line is gain crossover frequency. Right? So the phase at gain crossover frequency is pi gc. After that, what you have to do? You have to add, if you want to find out gain margin, you have to add gamma equal to 180 degree plus pi GC. So this is what the thing you have to find use for finding phase margin, right? So now we'll go to this problem, right? So now here I am putting a line over 0 dB for finding gain crossover frequency. You can see that gain crossover frequency for I am putting a line. You can see that my gain crossover frequency is cut it over this place. Here the 0.5 and 1. So between 0.5 and 1 we have 0.75. The value is 0.75 radian per second. Here 0.75 radian per second is the gain crossover frequency. If you want to find out the corresponding pi GC, what you will do? You will try to project this point. You will try to project this point. You will try to project this point over. Let me change the color so that it is. You will try to project this point over a phase plot, and you can see that the corresponding phase value is what? Can see what is the corresponding base value, that is minus 188. So if we want to find out the base margin, you'll be using 180 plus pi gc, that is minus 180 minus 88 is 92. So this is what the phase margin value. I hope we can able to follow this. This is the base margin. Now for finding the gain margin, what you'll do? For finding gain margin, you will be putting a line over which one? Where you will put a line? You will be putting a line over minus 180 degree. Here, is there any possibility for your gain? Sorry, is there any possibility for your phase plot will fall it onto the minus 180 degree? The answer is what? The answer is no. It is not at all possible for our scale, right? So hence we can call it as minus 180 degree at the phase minus 180 degree. You can't able to plot any value over the phase plot, so you can't able to find out what is the corresponding gain at the magnitude plot. Okay. Moreover, if you want to find out the magnitude plot, you can see that for example, you can see minus 180. For example, it is converged over here. For example, okay. Anyway, it is over here, right? So now, if you want to find out what is the magnitude, what you'll do, you'll try to project this over the magnitude plot. Can you able to tell me? See, this magnitude plot is going in this way. This magnitude plot is going in this way. This one is going in 180 and going in this way. Can you able to find out what is the corresponding? I mean, can you able to find the intersection point of minus 180 degree phase over the magnitude plot? The answer is impossible, right? The answer is never, right? So that's why projection of minus 180 degree phase into the magnitude plot is not possible. That's why let me consider gain margin equal to infinity. So that's it, right? So thank you guys.